Produced Water Treatment and Reuse by Bradley Wang for the 2021 Science Challenge. In the United States, 21 billion barrels of produced water are generated annually. Mexico alone generates 1.2 billion barrels. Every barrel of produced water costs a conservative price of $1 for disposal, but can cost up to $8 per barrel. This would cost at least $21 billion in the United States for produced water disposal. In addition to high-cost disposal, deep well injection has many difficulties, such as limited receiving capacity, potential for seismicity, and stringent regulations. Unregulated disposal of produced water is an even greater issue, affecting the environment by killing plants and animals, as well as polluting the groundwater and surface water. One way to minimize the environmental impacts and health risks of produced water disposal is to reuse this wastewater. Produced water reuse is especially important for arid and semi-arid regions, including New Mexico, where water is scarce and chronic droughts are the primary challenges facing local communities and economic development. Although because of the produced water's high salinity, it cannot be treated by conventional methods. For this Science Challenge project, I developed and tested a vacuum membrane distillation system to treat produced water from the Permian Basin in southeastern New Mexico. Membrane distillation is a treatment method used by heating water at low temperatures to generate vapor, then pushing the vapor through a membrane for condensation to collect pure distillate. The first component of the membrane distillation system is the heater, which heats water, which is then pumped through the system into the feed water tank. The feed water is warmed and pumped into the membrane reactor where it evaporates. The vapor is pushed through the ceramic membrane where it's pulled into a condenser and cooled into distillate by a vacuum pump and chiller. The water that does not evaporate is recirculated back into the feed water tank and through the system again. This is the aluminum oxide ceramic membrane. It is naturally hydrophilic and has a pore size of 0.1 micron. It's coated in a hydrophobic layer to allow vapor to pass through but prevent feed water from getting into the distillate. Thank you for watching my project for environmental sustainability.